All right, so we are recording up in this piece, and you know how this technology be going sometimes. See if we get these captions running. Yes, sir. Once again, it is E. Haley, aka Mr. Haley, aka that fool giving me all this math, all this math. Yeah. So we need to talk about, this next section of the lesson for this week, which is looking at how we can determine if a table that represents a function is quadratic or not. By now, you should already know how to see if a function is linear and if a function is exponential. So now we're going to look and see what does it look like when a function is quadratic. Okay, so this information you see on screen is very important. I will probably leave a link for you to get this information. You do want to write it down. Okay, so if a sequence of numbers has common second differences, then it can be modeled with a quadratic function. That function being f of x is equal to ax squared plus bx plus c. By now, you should know that any function that has a 2 on the exponent, and that's the highest number on the exponent, it is a quadratic function. Some of you already know this. You got the grade to show it. Some of you might need to go back and do some of the work that you tried before and get a higher grade. Remember, you can do more than one try on these online assignments. Okay, so today the student will know what second differences are. The student will understand how to find second differences, and the student will be able to take a problem and explain how they know if it is a quadratic or not. All right. So before we go into the quadratic part, let's review linear functions. If you see a table, how do you know if it's a linear function? You know this because it will have a set of common differences in the first finite differences. So the first finite differences will be common. If you look at this example, which you should probably already have in your notes, the common difference between the 2 and the 1, 2 and -1 is 3, 5 and 2 is 3, 8 and 5 is 3, 11 and 8 is 3. So it's plus 3 all the way down, so that means that it is a linear function. What about this function right here? Take a moment and see if you can calculate the finite differences. You do that by subtracting 9 and 1, 17 and 9, 25 and 17. So if you do that, what do you get? You get 8 and 8 and 8. So that lets you know that the common difference on this particular function is 8. And since that is finite differences, that means that this is a linear function. All right. So sometimes the table is leaning on its side, When it's doing that, you need to make sure that you know that the x's, which are the inputs, are on the top, and the y numbers, which are your domain and output, are on the bottom. You're going to do the same thing. You're going to look and you're going to take the differences of the numbers on the table and you're going to see if they are common or not. Okay. So in this case, all the differences are 1. So basically 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2, 1, 4 minus 3, 1. So the first finite differences are common. So that means that this is a linear function. Okay, we already talked about exponential functions. Yeah, we sure did. Exponential functions have common ratios. Okay. Remember, the word common means the same. So what you do is you look at the table and you try to see, does it have common differences? Does it have common ratios? Sometimes you find out that it has a common ratio. How do you calculate You're going to divide the numbers. 12 divided by 4, 36 divided by 12, 108 divided by 36, 324 divided by 108. All of those will give us the exact same number in this case. Don't believe me? Check the calculator. All right. So since the ratios are common, which means they are the same, that means that this particular table represents a exponential function of some sort. All right. Now let's talk about the star of the hour, which is the quadratic function, aka quad. All right. So how do you know if you have a quadratic function? Well, let's look at this here example that you see on the top of the screen. This is actually something that you should already have in your notes because this was in one of the first set of notes that you were supposed to be copying down. If you look on here, you'll notice is that the first differences are -1, a +1. I'm sorry, -1, -3, +1, +5, and 9. They are not the same, which means they are not common. All right. So that means that this is not a function that is linear because all those numbers would have to be the same. So what I can do is I take these numbers and I find the differences between these differences. And if I do that, that's 1 minus -3, which is a +4, 5 minus 1, which is +4, 9 minus 5, which is +4. So I take the number I'm looking at, I subtract the number above it. And that lets me know that I have a common differences on the second set. So this is called the finite second differences. Okay, so with a quadratic function, the first differences are not common, which means they're not the same, but the second differences will be common. Okay, so let's look at this example. This is actually the parent function for all the quadratic functions you will see. This is the daddy or the mama, depending on how you want to look at it. And all quadratic functions come from this f of x is equal to x squared. So if you look at the common differences, you will look at 1 minus 4, which gives you -3, 0 minus 1, -2, 1 minus 0, +1, 4 minus 1, +3, 9 minus 4. Come on, get off my screen. 9 minus 4, +5, 16 minus 9, that is +7. So notice that the first differences are not common. That means they're different. So what you do is you take the differences of the differences, which is called second differences. Okay. So when you do that, that is -1 minus 3, +1 minus -1, 3 minus 1, 5 minus 3, and then 7 minus 5. Okay, all of those will give me a +2. So the finite second differences are common. And what does that mean? What do you think it means? It means that this is a quadratic function. All right. So this is the methodology, the method that you use to figure out if a table is quadratic. And if this is not the case, then that means that it's not quadratic. But by the time you get to this point of the problem, you should already know if it's linear or you should already know if it's exponential. Okay, so